Now that we've explored some geographic concepts, as well as the scientific method, let's get back to our original question. What is geospatial technology? Remember, geospatial technology includes cartography, remote sensing, GPS, spatial analysis, and GIS. Let's define each component. But before we do, let's take a break from me for the next 5 minutes or so. Sit back, relax, and watch the Geospatial Revolution Project trailer video produced by Penn State University. For those of you following along in the PDF version of this lecture, please click on the link below for direct access to the YouTube video.
Say you're in California, where I live, and you want to know how susceptible your house is to a wildfire. So we put sensors, like our eyes, on satellites. We collect information, and then computers create maps. Okay, now you have a map, so you want to analyze that map. Well, you take the information about the slope. Are you on a dead-end street? Do you have a lot of fuel around your house? You put all of that information into a computer, and it can tell you how at risk you are for losing your home to a wildfire.
Ever since the Babylonians etched the lay of the land on clay tablets in 2300 BC, mankind has needed accurate representations of the earth.
Maps used to be made from horseback in the 1800s. They took a long time to make, so we evolved to aerial photography, and that's made a huge difference with how humans understand the earth.
And showing the terrain in startling vividness.
In the 60s, people began to think about the notion of encapsulating or abstracting geography in a computer. And people could look at the database in visualizations or analytics, and that was just a magical idea.
I, Barack Hussein Obama, do solemnly swear that I will preserve, protect, and defend the Constitution of the United States.
So help you God.
So help me God.
Congratulations, Mr. President.
The Obama campaign took to a new level their use of technology with respect to mapping.
They knew what voters to target. They knew, where the marginal voter was. And frankly, the ones that use it the most effectively get elected.
After 9/11, U.S. troops went into Afghanistan and they went in with Russian maps. Because who'd ever think you'd have to have maps of Afghanistan?
Geospatial intelligence has become really the foundation for just about anything that happens in the military. It has to do with understanding in a very time-sensitive fashion things that may be developing in different parts of the world. It's an ability to enable decision makers, whether they're someone sitting in the White House or someone sitting in a foxhole.
More than half the world's population now lives in urban areas. 13 of the 20 largest cities are on coastlines. So how do you model in the potential rise of sea level because of climate change?
We simply could not know how the Earth works without geospatial technologies telling us where things are, how they're related, how it's put together to tell us the story of what really is happening.
The conflict in Darfur is over 5 years old now. Somewhere around 400,000 people have died. We wanted to go to the place, collect testimony, take photographs. The Sudanese government had very little interest in having us on the ground. So we purchased satellite imagery, and we saw whole villages destroyed. We took those images to the Sudanese government to let them know that people around the world were watching these villages remotely.
For the insiders, the transition to digital geography has been truly revolutionary. That we can navigate our world with much greater confidence than we could have before. It's
changed the science agenda, it's changed the technology, it's created new occupations. But for those outside who may not even be aware that there is a field called geospatial, it has made geography ordinary, which is the most revolutionary thing of all.
That was pretty good. In about a 5-minute video clip, we now have a pretty good idea of what geospatial technology is, what it entails, and some of the things that we can do with it. Now, let's spend the next few moments talking about the major components of geospatial technology. There is cartography, which is the key to visualization and presentation, i.e., map making. There's remote sensing. Remote sensing is the collection of wavelength-specific data about features or phenomena of the Earth's surface and near surface without being in direct contact. And when we chat about remote sensing, there's really two major ways we look at it. There's active remote sensing and there's passive remote sensing. Active remote sensing really is a direct beam of energy pointed toward a surface, and then we analyze this energy that's reflected back, and that's going to tell us a variety of information about the surface. A good example of active remote sensing would be radar, which is radio detection and ranging. As opposed to active remote sensing, there's passive remote sensing. And in a passive remote sensing system, you're going to record energy that's actually radiating itself from the surface. And typically we're looking at visible light or infrared radiation. And once again, the whole goal is to try to find out information about the surface looking at this radiated information. In addition to cartography and remote sensing, there's GPS, global positioning systems. And with GPS, we're going to be able to find our location on the planet, pinpointing the location of objects and phenomena. There's also spatial statistics and analysis, which is the ultimate brain behind geospatial technology. Now, when we make our maps, that's collected from GPS data and remote sensed information, for example, what we can do now is look for point pattern analysis, autocorrelation, area patterns, clusters, networks. The goal is to take all of our information, we have it on our map. Now let's do some modeling and see if there's anything statistically viable on the map that we're looking at. This ultimately is going to be how we solve problems. And finally, the last component of geospatial technologies is GIS. So what is GIS? Well, Ron Abler of Penn State in 1988 made the following statement. GISs are simultaneously the telescope, the microscope, the computer, and the Xerox machine of regional analysis and synthesis of spatial data. Basically, GIS is the tool. It is the primary tool of regional analysis and synthesis of spatial data. In fact, GIS is so important, we're going to spend the remaining portion of this lecture really focusing on GIS.